Okay, my plan is to use this recorder here more consistently. I apologize that I haven't done that sooner, but wanted you to be able to have access to recordings if needed. Especially I knew with a lot of folks being gone, I wanted to make sure we record this one so that if you have questions or whatnot, we can work through and spend some time with that. Because of course assessment is tomorrow, right? It was supposed to be today, but we backed it up a day. So I am not expecting to go through this whole thing. Please understand there's no possible way I could go through this whole thing today. But I'm just looking for were there significant questions that you had for me in regards to the topics for tomorrow. Sir? Sure. Positive and negative feedback loops. Let me real quick pull up pictures here. So your feedback loop looks something like this, right? This is the example, and this is from your textbook. This is the example of body temperature. The point is that you have a set point. You have this place, this amount that the body wants to keep the same, right? Homeostasis, right, guys? This maintenance of this normal level. And when something happens to take you away from that normal is when these feedback loops start happening. The negative feedback loop is most common, right? What it does is when the body senses, when the receptors sense that there's a change. In other words, I'm warm in this place, right? Your brain, who is the control center, says, hey, okay, sweat glands, start releasing sweat. That would be the effectors. The effectors are the sweat glands that now start producing sweat to allow you to cool off. The blood vessels in your face would be effectors that then dilate, let more blood come to the surface so that you can get some evaporative cooling. That's why your face gets red when you're hot, right? All the things that your body does to cool itself down. As your body temperature goes back to that normal set point, the brain sees that and turns off. You don't just keep sweating indefinitely. You sweat for that small period of time while you're warm, and then once you're back, or while you're too warm, and once you're back to normal, you're good. Does that make sense? Same loop could occur, in the cold direction, but of course different effectors would be happening, right? Instead of sweating, you would start shivering. Instead of blood vessels dilating, they would constrict to keep the blood closer into your core. Make sense? That's negative feedback loop. Negative meaning you're moved away from set point and the body does stuff to bring you back to set point. So what's the difference between negative and positive then? You got one hand, that's it? Two, three? Only a couple there. What do you think, Ansel? Excellent. So it's not moving back to normal, it's moving further away from normal. You guys want to add something more to that? It's a positive feedback loop. Yeah? So in other words, instead of the effectors driving back to homeostasis, they're moving further away from homeostasis. Right? And they just keep getting stronger and stronger and stronger. The example we gave, a couple examples were what? Childbirth, pregnancy, the uterine contractions. And then what was the other one we gave? A blood clotting. Again, there are a few others. Positives are fairly rare in the body, but there are a few others. Yes, ma'am?
Wait, so negative is you closer to the feedback?
Set point, right? So negative, when things move away from the set point, the body does stuff to bring it back.
Oh.
Positive feedback means I move away from the set point, the body does stuff to move it further away. And then does more stuff to move it further away. Until finally, because you're trying to achieve some end, like you want something to happen. In this case, we want the baby to be born. We want the blood to be clotted, to be stopped from flowing. So you're trying to achieve a certain goal that's not necessarily homeostasis. It kind of is, but it's a different set point. It's a good question. Does that make sense? Good question. Good piece. All right, back to our outline here. Yes, ma'am.
What cavities do you want us to know?
The body cavities. The cavities that are in your textbook is what I want you to be comfortable with. So I'll give you some page numbers here. The body cavities, thank you, are the ones there on page 18. So the lateral view, the frontal view, if I can go back to our pictures, we're talking about this one, and we're talking about that one. Okay?
Do you want us to know the ones in the head?
No, I'm okay with that. So you don't have to go for the cranial ones.
Do you want us to know all the ones like proximal?
Sure, that's the relative positions. That's, if I'm back here on this paper, that would be relative positions, being to compare two parts of the body. So my elbow is blank to my wrist. And you would say the elbow is what? Remember, my wrist is the starting point, right? Elbow you're comparing to the wrist, so the elbow is proximal. And because it's on a limb, right, that's why we're not using superior or inferior. You would use proximal and distal. If I were to say that my nose is blank to my belly button, it would be superior. Again, belly button, the second thing is always your reference, and then you look at, okay, where is this compared to that? It's superior. Right? How about my ears are blank to my nose? Lateral, right? My ears are further away from the center than my nose is. My nose is blank to my ears. That'd be medial, closer to the middle. Okay? Good. So yes, you should be comfortable, and that's exactly how I'll do them. Sir? The systems of the body and the, oh yes, sure, you should be comfortable with that chart. We're speaking here about the body systems, major organs, functions, characteristics, requirements of life. Again, that is listed for you. Sir?
Should we know the parts of the thoracic cavity?
Again, those 2 pages you should be comfortable with. Yep. I don't need you to spend oodles of time on all the detailed pieces, but yeah. Other questions? Yes, ma'am.
Do you want us to know on the experimental versus theoretical part?
Experimental versus theoretical we talked a bit about on Friday. I just want to understand the difference between them. That experimental is what we actually tested, right? We pulled the chips, we calculated a number based on the actual people that were present, how probable it was you'd survive. The theoretical was based upon all of the people in the United States have this population, so theoretically you should have survived that much. If your sample's large enough, they should be the same, right? With 25 people, most of you were almost the same. A couple of you off a couple of points here or there. But that's the whole point. The larger your sample, the closer you would get to your theoretical.
So you want us to be able to explain or be able to do the math?
No, not the math. The math I'm not worried about. Understanding the differences between them. Yes, ma'am.
When you say anatomic position, you just want us to know what it is.
Can you describe it? Like how are the parts of the body in anatomical position, what do they look like? The palms are forward. The arms are relaxed at the side. Your toes are forward. Your head's forward. You're standing upright, etc.
Well, the imaging techniques, do you want us to know like what they're used for? Briefly about that.
Yep. The pieces that we covered in class. Again, there is that Wikipedia article because there's no place in your book that lists them like this. There's not. I went through, I could find a couple of spots, like there's a good piece on x-rays that's on page 148. There's a good thing about CT scans that's on page 25, but they don't have the whole, all 5 of these are not listed somewhere in the textbook. So that's why I put that article up there. As a quick, brief reminder, ultrasound is real life, real time, right? I can put that over a certain area and see how it's actually functioning in real time. I can watch the baby move. I can look at your intestines and see if they're moving the fluid and things through there. A CT scan is like an X-ray, but it's just in multiple layers. So you can get a little more three-dimensionalness to that. So it's multiple. It's using the same rays, the same energy as an X-ray is, but it's looking at different layers like an MRI is. MRI is using magnetics, right? You're using actual magnets to create polarities in the body so you can see. And that is, again, a three-dimensional viewing that it can be looked at in any of these different slices, frontal or horizontal or any of these pieces. X-rays, again, you know that, for bones, right? And that's using X-rays. And then, of course, direct visualization is the camera through either an orifice you already have or an incision that they make to slice it like into your knee or your abdomen or something like that. Question?
So do we have to know like the MI and soft?
Sure, you should be comfortable. Bones for X-rays, soft tissue certainly for CT and MRI. MRI is more detailed than CT is, so you get a better picture with the MRI than you do with CT.
Wait, the CT is more?
No, the MRI is more detailed. But a CT is more detailed than an X-ray, because that's only going to show the bones. That's not going to show as much soft tissue. Other questions? You're good? Okay, what I want to do then is I want to give you, excuse me, I want to give you this time to spend working. If you have questions, Mrs. Serrano and I are both around. Use this time wisely to work.